All right, everybody, welcome back to the Elastic Live user group brought to you by the official Elastic community. I'm Jay Miller, developer advocate at Elastic, and with me today is Colton Myers. Hey, Colton, how's it going?
Hey, great. How about you?
Doing good. We're here to talk about APM, which I am still learning lots about and we'll have a bunch of questions. But if you're in the chat and you have your questions, be sure to throw them out. Or if you just want to say hi, like our good friend Seth did, you can do so also in the chat. And if you're not yet, be sure to subscribe. Let's kick it off first, Colton, by getting to learn a little bit more about you and kind of your story of how you got into Python, how you got into APM, and how you got into Elastic.
Yeah, my story is, I don't know, it's a little bit odd actually, because I mean, how I got into Python, that's less odd. I found it while I was at university and loved it, fell in love with it. It works just how my brain works, right? Like, so compared to other languages, I have to Google for so few things because things are usually named the way that I think that they're going to be named, and everything comes batteries included. Python is a great language. As far as my Python career goes, is a little odd because I am not. Most people who are Python developers are app developers, right? Django, web for Python, right? Or in the scientific community. Those are the two biggest cadres of Python developers. But my whole career, I have been working on basically application Python. Specifically, I started my first Python gig was at SaltStack, designing CI tools in Python, and then I worked at Adobe working on security tooling in Python, and now I work at Elastic working on the APM agent. So yeah, I don't come from a web background, which is a little bit odd for a Python developer, but definitely in the web now because that's a huge part of what we do with APM.
Well, that makes me feel better, so I can say yes, Flask better than Django. Anyone who's a web developer on this stream can fight me. Just kidding. It's always love, but I learned on Flask, so for me, Flask always has a special place in my heart. It's interesting though. So like when you start looking at like application and APM, what are some of the things that make Python a good tool for it? Because I mean, everyone talks about the easy to read, easy to understand, makes it great for data scientists. That way they don't have to learn like a whole paradigm of thinking, a whole different way of thinking to program. And then you also think about like some of the web and Django stuff. The way that everything is set up is pretty cut and dry, and Django a little bit more magical than some of the other ones. But what makes Python great for application performance monitoring?
I mean, the reality is that it makes it great because people want to use Python for web apps, right? And if we're going to monitor a Python web app, it's probably that tooling is probably going to be written in Python, right? So that's really the reason that the APM agent is written in Python, because what else are you going to write it in? But yeah, it's the nice thing is that Python allows us to do some cool things, to automatically instrument all of your underlying libraries, that we can collect information about libraries without you having to say, hey, go collect information about urllib3 calls, go collect information about Redis calls, right? We can do all this stuff automatically because Python is so extensible and allows us to, kind of monkey patch in the background and wrap things. So it makes it a great language in that case, because, for example, I don't know the details, but I know there's always a conversation about auto instrumentation in the Go agent, and that's harder because of the way that you compile Go programs and the like. So we don't have those problems on the Python side. Now, granted, we can't do it as automatically as something like the Java agent that can just connect to the JVM magically without you doing anything. Like that's super cool, and I kind of wish we could do it in Python, but we can't. But it's pretty easy to onboard, and we can do a lot of cool things automatically. With just a few lines of code in your application. So
I'm starting to think of stuff like Pigeon and like Iron Python but no, we won't go down that road. Let's talk about APM itself. For those that don't know, like what exactly is APM from an
so
Elastic
APM
standpoint,
stands for It stands for Application Performance Monitoring, right? You have a web app, and when you have a few customers hitting that web app for a few requests a day, you probably don't really, I mean, you have a lot of overhead, or sorry, you have a lot of resources that, you know, you're not going to worry too much, right? But as you scale up, all of a sudden you're having to, you know, get load balancers and do all these different things to scale your web app, and all of a sudden these performance gains or these performance bottlenecks become a lot more important, right? And so APM allows you to get insight into performance bottlenecks, errors, user experience stuff before you have to have a user tell you about it, right? If a specific request in your application is slower all of a sudden, right? You might not know about it until a user comes and tells you, and that's a bad thing, right? You don't want the user to be telling you that something is slow or something is erroring or whatever. You want to know before then, right? And especially if it's an error that only happens sometimes or only with certain pieces of data, right? Like, how are you going to solve that based on user reports, right? You need something that is reporting all the time and sampling your transactions so that you can see these problems earlier and catch them and solve them and save yourself, you know, money and money based on compute resources, user experience, user satisfaction, right? You want to keep everything running smoothly and catch issues quickly and be able to basically drive your mean time to resolution. That's the MTTR, right? That's the metric, and we want to drive that as close to zero as we can, right? We want to resolve issues quickly. We want to track them down quickly. Yeah.
I like that. And I think that was, you know, we talk about log ingestion a lot, you know, with Elastic, and the idea of a thing happened, we get it in near real time, and we're able to give you a good idea of what's happening around the corner. And I feel like this is a step beyond that. This is like, yeah, it's not just log ingestion. It's like, hey, what's happening in the now? And it's having everything, as you mentioned before, connected so that you don't have to go, okay, hey, what is this log? What's the format of these logs? How do I get this ingested and everything in? It's like, no, this piece is connected to this other piece, which I think is really neat, but also provides information that may not be readily available in just the most basic of log.
Right, and the super cool thing is that we can integrate. You know, we love log shipping, right? And we can integrate with that on the APM side. So if you use if you use ECS logging Python, which is a library that we provide to, you know, format your logs as ECS, and you're also using the Python agent, the APM Python agent, those will work together to basically insert identifiers for specific transactions and traces. We'll talk about traces more in a minute. Into your logs, so that then when you're looking at a trace that is problematic, when you're looking at like, oh, this specific path in my app is slow for some reason, right? You can just click over and say, hey, show me the logs for this transaction, right? I want to see, because I know I have the information there, but like I want to quickly jump over and see what we're logging in this case so I can look at like additional data or whatever. So that's super cool too. It all works together, right? The more you ingest with, you know, Elastic's observability solution, then the more data you have and the easier it is to find these issues, right?
Definitely. And that's been one of the things that I've been preaching now. I've gone on a few panels where people are talking about, you know, knowing exactly what you need to store, because, you know, obviously, you know, for some of them, you're talking about storage being limited. And I was like, okay, in most cases, storages won't be limited. Storage will actually be the cheapest thing that you have. Just grab everything, like just the kitchen sink included, just bring it all in, make sure you have it. And then it's our job to make sure that we can surface the right information instead of you worrying about whether or not you brought it.
Sure. And at the same time, we want to make sure we point out that we have sampling settings that you can set basically to not store everything, right? Because the reality is if you're doing millions of transactions a minute, you probably don't want to store all of that, but we can sample 10%, 1% of those. So you always know you're going to get a representative sample of the stuff that's happening in your app, right? So even if storage is a concern, you can be sure that you get the data that you want, but you don't have to store the world, right? Because it can get expensive. And we're introducing new features around this, right? Tail-based sampling is coming. which basically allows you to offload the sampling decisions from the Python agent to the Elastic agent or the APM and the APM server on your local host, which will then make sampling decisions and basically can drop a lot of extra data, but keep the statistics about that data, so you can basically, we can reduce the amount of space that you're using in Elasticsearch, but maintain all of the important data points about that data. So it's super cool. Keep an eye out for tail-based sampling coming soon.
I love it. Well, I know you've got some stuff that you wanted to show us, and we've got plenty of time. Also, just to mention again, before we jump into all the demos, Elastic Community Conference, Elastic CC, is happening again. We are back. Last week we did kind of a things you need to know. We're not going to be meeting next week because of the holiday, but then after that, we're going to be doing some office hours. You can submit your CFP today. You can use that short link. There's a longer link. I like this one. This one's kind of cool. I'll also throw it in the chat for those that want to save that for later. But enough about that. We'll come back to that a little bit later on. Let's see what you've got for us to kind of give us an example of how we can tie into APM using the Python client.
Sounds perfect. Yeah, so I just landed. I had this open earlier. Just if you want to learn more about our broader APM offering, we have a dedicated page right on elastic.co underneath our observability stuff, and you can kind of see some of the things. And I'm just going to show you a lot of this. So I have some sample data here, right? So this is Kibana in our observability tab under APM, right? And we have all these services with sample data, and including a Python one down here, right? And so we can go into this Python one. This Python one is not going to have data for me apparently right now. All right, well, this is going to be bad for Python, but I'll show you some Python data in just a minute here because we're going to explore some other things. But let's go look at one of these that has data. Okay, now it really hates me. Okay, so let's go check out Java here. So you have a service, and the Python data looks very similar to this, right? We can see latency, which we have the average latency over time. We can see our throughput, our failed transaction rate, right? This data set is designed to have errors, right? So we can see errors. So for example, we can see, oh, we have a bunch of occurrences of this unable to acquire JDBC connection, right? We can click into this and see this error. The more interesting stuff, most of it, like errors are great. We want to know about errors, but we also want to know about the actual transactions themselves. And so we can go in here to a specific transaction, which generally is a specific code path through your app, right? And we can see, okay, this is not a very good waterfall. Let's find a better waterfall here. Here we go. This one is one that's erroring right now, which is interesting. So you can see we're throwing a 500 internal server error here, but you can see, okay, we started on this this dispatch servlet do get. It did a request to this get op beans, which jumped over into a different app. You can see it's blue over here, this op beans node. So now we're in this node app. So it actually it's keeping track of this distributed trace across all your services, right? We live in a microservice world, and we want to see how this waterfalls through the whole infrastructure, right? We don't want to just see one microservice. So this shows you the whole thing, right? So we're in the node app over here, and we can see each piece here. These are called spans. These sub pieces are called spans, and these are all failing. So this is a really bad transaction right now, but it's sample data, so it's going to have a lot of errors because we want to see that. Yeah, anyway, so this is just some of the stuff. If you spin up a Kibana instance, there's like sample APM data that you can have it load in, which allows you to kind of look at this yourself. The cool thing is too, we can see like a service map of all of our services, which is super cool. So we can see, okay, we have all these different paths, options, this RUM, which is like in the user's browser, right? This is your client side information, calls into all these different services, and you can see, okay, here's to the SQLite, here's to a Redis database, right? Like a Redis database, that's not the correct term, but Redis cache. But here's our Postgres database, and you can see how this data flows through this, right? So that's super cool. And then yeah, you can solve issues based on, oh, is everything slowing down as it's talking to my Redis? Then we need to probably scale it up or figure out what's going on wrong there. So all right, some more information here. I guess I should check. Is there any questions so far? Nope. All right.
So far, so good.
Yeah. So the Python agent is public on GitHub. It's let's look at the license. It's
a BSD
BSD 3
license.
clause. Thank you. I was spacing on BSD. My brain wanted to say GPL. It's definitely not GPL. So it's BSD 3 clause. Most of Elastic stuff we try to have Apache 2 unless it's under Elastic license. But this due to some legacy code and so forth is BSD 3 clause, which is very permissive. So it's usually not an issue. And everything is open source. That's super cool. You can come and see what we're working on. You can contribute bug fixes, PRs, or bug fixes, features, whatever you want. In fact, we just had a super cool contribution from the SANIC community. So now officially we'll have SANIC support as soon as we release a new version, which actually I think is going to be tomorrow. But we have support for the SANIC framework, which is super cool. And that was a completely community-driven thing. So that's cool. We have docs. You can get to those from here. We have the documentation linked here, or you can just search APM Python Elastic. Right, it'll bring you here. And we have all the docs for how to set up the various integrations. Right, so the easiest way to use APM is with one of these frameworks. Right, you go into Flask and you say, okay, we just have to import our library. Create your Flask app, and then wrap it in our Elastic APM object, right? And you should have a service name and your token for talking to the APM server, that kind of stuff too. But it's really this simple, and now all of a sudden you're going to get spans from everything underneath that, which is super cool. You can see we're going to go to supported technologies here. And we can scroll down here, and we support all of these different libraries, right? MySQL, AIO PG, which is a Postgres library, PyMongo, AIO Redis, Cassandra. Like, we support, all these major libraries, right? And we're going to collect data on all of these different things. The most important of these being the HTTP libraries, in my opinion, because that's how we connect to the next service in the line, right? When you're doing REST calls to your microservices.
It also helps that we can poke the maintainer anytime we run into some issues.
Yeah. Shout out to Seth, who is in our chat and is one of the URL 3 maintainers. Super awesome that he is here with us at Elastic. But yeah, this is super cool because you don't have to do anything. We just collect all this data, right? So yeah, if you want to collect custom stuff, we have features for that too. So we can go over here to our API. And we can say capture span. So we have this thing that allows us to capture arbitrary spans, right? Remember, spans are just one little piece of that waterfall that we were looking at earlier. And so now we can say, okay, we have this custom function, and we want to know anytime we hit that function, we want to know how much time we spend on that function, etc. We can just put this decorator on that function, and all of a sudden we'll just have that data, right? So we will now see anytime this is called, it's going to show up as a span. We can see how long it spends there. We can see data about that spot, right?
In order to avoid a waterfall of, do you support this particular tool or platform? I will bring up the one. Do you support Neo4j? And then if the answer is no, what is a good way for people to express what, how do you add something that's missing, or how do you even request that something be added?
Yeah, so that's a really good question. I don't know Neo4j, which I'm gonna guess means we don't support it. Let's go find out. Supported technologies, Neo. There's nothing Neo.
Yeah, this would be the way to do it, I guess. You come here.
So, yeah, what you do is you come over here into our repo, and you go into issues, and you say new issue. I want a feature, and you tell us about it. What is the library? et cetera, and we usually add it. I will, assuming that whatever Python library supports Neo4j implements DB API 2, which is a standardized database access API, basically. That makes it a lot easier to add. So hopefully that it follows that process, because that makes it much more likely that we're going to add it, because it makes all the database integrations very similar. But yeah,
it sounds like basically, depending on how their architecture is supported, will support whether or not we can easily or not so easily support it, or as something simple, or if, you would need to maybe rely on the community a little bit more for those custom implementations.
Yeah, I mean, we want to support the major libraries, right? Like we want to support things that people are using, because that makes the agent much more useful, right? But we do have to write these, right? So if we go into contrib, you can see all the things that we write. So if we go, these are tests. I just go here. You can see all the stuff, right? So
I saw Starlet, which is like Fast API.
Yeah, sorry, that contrib is for like the frameworks, right? But we want to go into here into packages, so we can see we have to, when we support GraphQL, we have to write a GraphQL integration, which is not huge, but not tiny either, right? And we have to write tests for each of these, right? So it's not terrible to write new integrations, but it's not usually trivial either. So yeah, anything we add, we have to write, and that's basically a wrapper around the functions in that library that we want to keep track of. So, but yeah, open a feature request, please. Like that's how we judge interest, and that's how we decide, where we're headed next. Is we open a feature request, other people +1 that feature request, et cetera, right? So yeah, great question, by the way. Okay. Cool. So yeah, you can get all sorts of stuff about our API and all of our config options. We have a lot of config options from that you can tune for performance issues, or you can tune for how much sampling you want to do of your transactions, etc. Like I talked about earlier. There's a troubleshooting doc. Oh, we also have, under Setup the Agent, you can see an instrumenting custom code section, right? This is okay. You aren't using Django. You're using something in house. You're using something that you can't automatically get these transactions. In that case, you have to actually make the transaction with our client object, and we have some information here for doing that. But it's a little bit more of a pain, but it definitely is supported, and we have lots of people doing that. So, any other questions so far? Doesn't look like it.
I don't see any questions. One of the questions that I have is how do we visualize this? I know one of the great features of doing everything through the Elastic Stack is kind of everything is connected. And in my mind, I see Flask there, and I immediately look at like, okay, hey, I have Flask websites. I feel like I should be wanting to do this. Cool. I set that up. Now, what am I looking at in my day-to-day?
Right. So I just need to find out where this data is.
Oh yeah, I forgot we had the op-beans Python.
No, we got it. I just
okay,
we're here to go find the data. Here we go. So this is an example of what you might see, right? So you have some different views in op-beans. And this is our op-beans. We have a Django one and a Flask one. I'm guessing this is Django. Yeah, so you put this in here, and now so if you put this in Django or Flask, right, all of a sudden all of your views or routes will just show up here, right? So in Flask, all of your different routes are just going to show up as individual transactions here, right? So for example, and then you can see whenever anybody hits one of these, right? So if we're in the product customers view in our Django app in this case, we can see, okay, when a customer hits this, when a user hits this, they got a 2xx, right? It was a successful hit. We get this opbeans :3000 thing, which is into the opbeans Go app, right? So we're calling into a different service, right? And we get the information there of how long it's taking in each section there. Calls out to opbeans Java, right? This is kind of an arbitrary, all these opbeans, right? So many opbeans. By the way, opbeans, that comes from our APM agents started out as opbeat, which Elastic joined forces with 4 years ago. And that's where opbeans come from, because it's opbeans anyway. And so yeah, that's where that name comes from. But you can see basically the whole path through this transaction, and that lets you see, okay, we can say, okay, it's taking a long time, a lot longer than we think in API products ID customers over here in the Go app. And now we can go see what's going on there, right? We can even click through and see metadata about the user, for example. Let's find some useful metadata in here. You can apply custom labels to your stuff. We can see exactly when it's happened. We can see the version of the Python agent. We can see the client's IP. We can see a bunch of stuff about where this is running in our cloud infrastructure, right? So that way, if we are seeing problems in maybe a certain availability zone or something, right? I don't know. We can see a whole bunch of information about the HTTP request. We can see the user, some user information. Yeah, all sorts of stuff. So yeah, that's the kind of stuff you can see. You can go see your logs for this. We'll see if there are logs for this. I'm not 100% sure that we have. Yeah, okay, we did. Perfect. So you can see your logs here. Cannot index event publisher. Fun. I don't know what these logs are. That's not super useful, but hopefully your logs will be more useful. You can see, okay, we have our opbeans Python service, and we can see what dependencies it has. Okay, this calls out to Redis, opbeans.net, right? Like these are the dependencies for the service, right? And we can see issues, latency issues, right? Throughput issues, failed transaction rates on those things, right? So this is failing 100% of the time against Elasticsearch. That doesn't seem good. We can see errors. So a lot of these are contrived, right? Bad luck. This is the assertion error. Bad luck, and it's an unhandled error, right? But we do that in our sample data just so we can see things. But some of these are more typical, right? Page not found. Cannot use none as a query value. Whatever. So you're basically, you can just see, and a lot of this is on the overview, right? When you go. Maybe. Come on, you can do it.
I will always tell people, anytime you're sharing your screen over the web and also trying to do things on the web.
Okay, yeah, so we can see these errors and recent occurrences, right? We had an error spike. We had 4 occurrences of this read timeout thing, right? So, and that was 16 days ago, right? That's not super useful, but yeah, we can see, oh, like right here, if there's a spike in failed transaction rate on views.stats, right? Like that's something we want to look into. If our throughput is going down or up, right? That's something we want to look into. Or if our latency has big spikes, that's something we want to look into. It just gives you, like, when things are running smoothly, you're probably not going to care too much about this data, but as soon as shit hits the fan, then you might care, right? And so, excuse my French there. All right, so.
One thing I've noticed that we've talked about a lot is this is great for when you're seeing things that are not so optimal. What about things that are, and I don't want to say too optimal, but like, is there a way to do an adjustment? And my one thought of this is, if I'm looking at things like server load and beats, and I'm saying like, okay, hey, everything is running at 0.001 milliseconds. This is great, but also my bill is $1 million a month. Where can I start looking at places where I can make optimizations? Is APM a place where this information can be gleaned? And if not, that's fine.
I mean, I don't think you're going to see I mean, so we do gather some system metrics. We're not as good as metric beat on that, right? Because we don't want to spend a lot of time. So like install metric beat too, right? But or the Elastic agent, and so you're going to get system metrics that way. You're going to see that you're not running into big latency spikes and issues with your app, right? And then maybe you start tuning. Maybe you put one less instance behind the load balancer or whatever and see if everything stays kosher, right? Like, but so yeah, you're going to use these things together to maybe make those decisions as you kind of scale things back. But hopefully, right, what we really want is more and more, right? More, we want these issues to happen because that means our app is being used, right? So right. I think that's the use case we focus on. But you can definitely see information about, places that you can slim down via metrics and that and the like. So
yeah, maybe it's more of a, like you said, you use metric beat to kind of figure out what resources are being underutilized, or I guess over spec'd. You start scaling them down and then use APM to kind of gauge how that scaling is taking an effect on your entire system as a whole.
I think so. Yeah.
Yeah. And then I guess the other question that I had was, and which, by the way, if anyone else has questions, feel free to throw them in. I'm learning, so I will use this opportunity selfishly as long as I can. One of the things that I also noticed here was the ability to kind of drill down as things were happening. And you mentioned the idea of sampling. Are there thresholds that can be set to adjust how much information you're bringing in at any given time? Yeah,
for sure. So if we go over back to our docs here and go to config, we can say sample transaction sample rate. So by default, we're going to sample 100% of your transactions, right? And that's and so you probably want to turn this down if you have a lot of transactions and you're worried about how much space you're using on your Elasticsearch cluster, right? And so you can set this to 0.1 for 10%, right? And now we will just sample 10% of your transactions. And unless it's a problem that only happens 1 in a million transactions, you're probably going to get a sample of the issue that you're seeing, right? And if an error happens, even in unsampled transactions, we report that, not with as much data, but I'm pretty sure we report the error. So you'll still get that in your overarching, because even unsampled transactions, we currently collect just basic like duration and those types of information for unsampled transactions. So you can still get kind of the breakdown metrics and see like overall patterns of what's happening in your infrastructure. And tail-based sampling is how we're going to reduce the data that we save with that, because we're going to basically collect all those metrics and then throw away the drop transactions, which is cool. But yeah, this is one way you can do it. For errors, we collect like stack frames and so forth, and you can actually, there are a bunch of different things for stack trace limit, for example. Like, okay, how many stack frames are we actually going to collect? What's the minimum duration of a transaction that we actually want to collect frames for? On errors, we collect local variables, which is super cool. All sorts of stuff. So there's a ton of stuff you can tune if you're collecting too much data and the like. So take a look through this configuration document.
It makes a lot of sense. And then we did get a question from our friend Seth that says, is there anything special that APM has for cloud, like GCP, Azure, and AWS?
Fancy. Seth is throwing me a bone here. I don't know if it's throwing me a bone here, but I totally have some stuff up here that we're going to talk about with Lambda specifically. So we do have a bunch of AWS, like, so we use Boto Core. We have an instrumentation for Boto Core that allows you to basically collect spans about your interactions with AWS services. So that's one piece of AWS. We have similar things for Azure. We've done block storage and, oh my gosh, spacing here. Let's go look at our releases because it was recent. Yeah, so in 6.6.0, we had AWS Lambda instrumentation. We're going to talk about that. We had maybe it's 6.6.1. Where am I? Here we go. In 6.5.0, we added instrumentation for Azure Storage, Blob Table File Share, and Azure Queue, and we have some more Azure stuff coming. We have less on the GCP side, GCP specific things, but we're always working on improving that. And anything that runs on GCP, Azure, AWS, we're going to collect cloud metadata about the host on which that runs. So you'll get, we were looking at over here, we were looking at the metadata for this. And you can see your region, your instance ID, your instance name, your account ID, all sorts of stuff. All that stuff we collect for all three of the major providers, cloud providers. So that's a thing. And then just recently we added support for Lambda. And so here is a Lambda function. I'm just going to demo it a little bit. This is super simple. This is basically, I'm not going to share my VS Code. And of course, I uploaded this as a zip, which means you can't see it in here. But basically, it's like a function that sleeps for a third of a second or something, and then calls another function that I am capturing the span on, and that sleeps for another 0.2 of a second or something. Right. So it's just to give us some data to look at. It's a super simple function, but yeah, basically now we support Lambda. So I guess I need to go pull up this, at least you can see how easy it is. So in Lambda, basically you just need to add us as a dependency for your Python function. That could be just a requirement.txt file if you're using like serverless framework, or it could be installing it into your target directory that you're going to zip up and upload. However you're dealing with dependencies in your Python Lambda function. But basically, once it's there, you import this function, this decorator, stick it on your function, stick it on your handler function, and that's it. Of course, you'll need to also add some configuration in your environment variables. The really cool thing that we've done is we have added this extension layer. So for a long time, the problem with Lambdas was, okay, how do we make sure that we can send the data to Elasticsearch without delaying the return of your function, right? Because if we just block and send at the end of your function, you're going to sit there and wait, and whoever called your function is going to be waiting for us to send to Elasticsearch or to the APM server, and they won't have their return. So it can add a whole bunch of overhead to your functions, right? That's not ideal, especially if it's a microservice that is, only takes a few milliseconds to run or something like that. And so the cool thing is that recently AWS added support for Lambda extensions, which gives us basically another runtime underneath that can finish up some stuff after the function has returned. This means, so it still uses the compute that it would have, like the overhead in terms of your Lambda billing is not is pretty similar to if we were blocking, but the user experience, the service experience is much better, because now you're going to get your return immediately, and then we send to Elasticsearch. And if a function is getting hit over and over again, we are sending in the background throughout. So it actually does do better in terms of compute as well, in terms of billing on your function. So we have this APM Editor Lambda, which I have already put on my functions. You can see down here this layer, APM Lambda extension. And that requires this cool config option, right? So we're going to be sending to localhost, because the extension is running on our function's effective localhost. It's running on the same host. And we send to that extension, which then sends to Elasticsearch with this, which is, or to the APM server, wherever it is, which is right here. So, yeah, so yeah, that's the function. Right here, this is just invoking the function. The function is also just, it's sticking the whole event in its return. That's what all this gobbledygook is. It just lets me see what Elastic, this is what I was using when I was developing, because I wanted to know what was in the event object, so I could pull out all the relevant data. So if we run this again, we're going to get fresh data over here in my cloud instance. Yep. All right, so we don't have very much data for this because I just run it manually over here in this. But you can see that we have this waterfall. This is okay. I guess you probably can't see this, so that's okay. there's a little thing that's overlay on my screen. Anyway, so basically we can see that we did the get serverless testing dev hello, and then we do this do work function that I talked about. It's just a function that I put capture span on, and we can see that everything was okay, and we collected a whole bunch of metadata for that. I don't think I'm running. Yeah, I need to be running the newer version of Elasticsearch, which I'm not currently running on this instance, to be able to see that new metadata. But we collect a whole bunch of cool metadata for, including like cold starts and a whole bunch of information for your specific function. And yeah, that support is available right now, and it's pretty awesome. So if you're interested in checking that out, hit us up because we'd love to know how it goes for you. And if you have additional any issues, if you have any input on what you'd like to see in Lambda. We don't currently have immediate plans to do GCP cloud functions and the like. I can't hide that. Great. Because we don't have this extension support in those places, right? So again, you run into this problem of like, how do we get the data back to Elasticsearch without delaying the return of the function? But hopefully Google Cloud Platform will add that support soon, and we'll be able to extend this to there as well. I know we have at least an internal customer at Elastic that would really like to use that, but we can't yet. We can't do it right, so we're not doing it yet.
That definitely got me thinking about things like Netlify services, like serverless stuff, and like Vercel. And my challenge is always, I love static and I love just like push deploy and then it's there, but I would still love to actually know like, hey, on the back end, what's kind of happening there? Is there something that I'm doing wrong? I don't know if this gives us visibility into things like that, but I definitely like the direction that this is heading, because what that does is that gives you visibility into, I don't want to say the magic, but there for some folks it is a little magical of like what's happening behind the scenes, and when things stop happening the way that you expect, it's nice to be able to have a little bit of visibility as to like, okay, hey, is it just me or is it something that's happening on, down the road? Actually, a good example of that was, about an hour before we started going live, we had an issue to where the provider that we use for these live streams went down, and we were like, okay, what's happening here? And obviously I can't troubleshoot for them, but I can send them plenty of hugs along the way. But it would be nice to know that like, hey, the issue isn't on our end, it's actually somewhere Google load balancer issue. So like, usually there's a lot of times where like in an outage, the first question you can always hear is, well, why is it broken? And it's like, well, that's what we're trying to figure out. So if we can figure that out, and we can figure out that it's not actually us, that it's somewhere further along the pipeline, then the more like infra engineers are happy, which I'm sure they usually
for sure. Like if your function is calling out to an external service, right? That external service may not have, you're not going to have APM data coming from that, right? Probably. But you will see in your waterfall, you'll see, okay, everything was going well until we called to this service. It took a long time and then timed out. And that's where the error is coming from. Oh, okay, it's on their stuff, not on ours, right? Or, something happened, right, where our authentication is wrong or whatever. You'll get your errors, right? And we don't have a lot of the magic. We don't have all the magic there that we want yet on Lambda. Like we would love to be able to correlate with your CloudWatch logs, right? But we need to, do a little bit of work with, like the FileBeat team and so forth to make sure that we can put those logs out in, so that FileBeat can collect them and then we can correlate, right? Like there's work to do. This is experimental, right? It's out for people to use, but we definitely want to improve it, right? Because we'd love to have it so that you can just go to Kibana as your first point of like, hey, something's going wrong with our Lambda functions. Like, let's go look, rather than going and getting into the AWS, console and going to CloudWatch logs, right? Like that's, we prefer to have you just go to us, right? We want to have everything there for you. So,
yeah. And I think we have another
Seth,
question. Yeah.
I was just about to address that one. Seth, I'm not familiar enough with Google Cloud Run off the top of my dome to answer that question, but I don't know.
Yeah. And of course, I think with kind of all of the things that we've kind of mentioned here, a lot of this you do have access to through like the logging side. It's just there's kind of more to the story there. When you're looking at it from the idea of APM, you're tracing back through your application, so you have all that visibility of what's happening as it's happening, instead of having to say like, you mentioned using something like CloudWatch, where I'm sure you could get those CloudWatch results and then feed them into something, Elasticsearch-esque, and then visualize that in Kibana. It's just with APM, if those features were available, you wouldn't have to. It would be pulled, which again, that's not necessarily saying like, oh, this way or that way. It's we want to create as many ways as possible. And Seth has heard me harp on this, 1,000 times at this point. Like, the features that I love the most with the Elastic Stack are always the features that we make for people who are not living in the Elastic Stack. Anytime that we can take someone that says, hey, I have to use this because my boss said use this, and we show them how easy it is, and they're up and running, and it's like, oh, now I actually want to use this because it makes my life easier, not, oh, I want to use this because of the actual information that it can surface. Like, it's great that we can do both of those things, but the fact that we can do it so easily is, to me, the advantage.
And that, like, we've been working really hard to make onboarding, a big focus on the agents team has been like zero config, or as close to zero config onboarding as we can, right? How can we, I would like to, at some point, we're looking into making like a wrapper script, basically, so that you could just, instead of having to actually add code into your Python app, you could just wrap your Python invocation with a script that would basically do all that for you. So this is not necessarily making it easier to onboard, but it's allowing you to onboard at the SRE side instead of at the dev side if you want, right? If that's how your company works. This is something that we want to do. We're always looking for ways to smooth the onboarding, basically make it quicker we want you to quickly be back to running your app and using the data that we're gathering. We don't want you to have to spend a lot of time fiddling with our products. So,
absolutely. Well, anytime I have an engineer here as we get ready to wrap up, I always want to ask, what can we talk about that's on the horizon? Obviously, we have 8.0 coming up, and everyone's super excited for that in the new year. Are there any things that we can look forward to in the big update?
Well, the one big thing that I'm super excited about is that Elastic just joined forces with Optimize, and we've had some internal demos of their Prodfiler product, and it's super cool, and it's going to add a lot to our offering. Right? It's just another really cool data point of like this real-time profiling in production, right, of everything that's happening on your host, and it's super cool, and I'm really excited for it to like be a product that we have in our Kibana and so forth. That team is working super hard to integrate with Elastic Stack, and I think that's a huge thing to look forward to. On the APM specific side, right, we have tail-based sampling that's coming. We have a lot of integrations with the Elastic agent and fleet, which is all 8.0 stuff that you should be looking forward to. And yeah, I think we're always just like, sometimes it can feel like APM is a little bit boring because we're just adding new instrumentations, right, for new libraries. But like we're always chugging along, gathering more data, broadening our surface that we collect data from which we collect data, and just trying to always collect more useful data for you without, obviously we don't want to increase the resources that we use or anything, and so yeah, that's our goal. And yeah, nothing huge to share on the Python side of things, except like I talked about, that wrapper script is something we're looking into, and obviously all of the other things that are broader in APM that the Python agent is coming along for the ride too, like tail-based sampling. So
I love it. And of course there's an easy kind of wrap up question around Star Wars that I could throw, but I'm going to actually use my observation skills to say, "Hey, what board games do you like?"
I have a ton of board games. I don't play them often enough. It turns out when you have 3 young kids, it's hard to get out and play board games with people. But I really like, a lot of the different. I've really liked the Legacy series that has been coming out, like Pandemic Legacy and these other like longer term things. I really like Gloomhaven. I really like Dungeons and Dragons, and other role playing games like that. I just don't get to play them very often because right now we have kids that are young enough it's hard to find babysitters for. So one of these days we'll get more involved. But
I mean, you have a small party there. You could just DM your own campaign with your kids. That sounds like it'd be a lot of fun, right?
Yes. The 3-year-old can play. I don't know.
It's aggro. So I have a 3-year-old. It's so much aggro. Like the first to run in.
She fires magic missiles into the darkness all the time. I don't know.
But, oh yeah. Man, maybe we'll have to do that. I'm seeing a Board Game Elastic community stream. I mean, this is the community channel, so I would love to kick off some D&D campaigns. We'll call it like the search for something. I don't know. We'll get there.
Oh boy.
Well, Colton, it was absolutely awesome having you join us for our little hour time here. And again, as always, I want to first of all thank my guests, but also let people know, like, if you have any questions, obviously this is going to be on YouTube. So for those that are watching and that have watched, this far along, thank you. That's awesome. But also, if you have questions, you can leave a comment in the chat. You'll still get it. We'll be happy to come back and answer those questions. I can always ping Colton. Also, if you just want to throw that question in our Discuss forum, you not only get access to folks like Colton who work for Elastic, but you get access to the greater community of people who have probably done something similar to what you're trying to do. And that to me is always the easiest way to go about things. And of course, if you just want to chat about it, you can go to community.elastic.co to see what other events we have going on. And you can always ping us on Twitter, LinkedIn, all the socials at Elastic. I don't monitor this channel, but I do want you to blow it up and like send all the comments saying, "Hey, I watched this video. It was absolutely great." I have 1,000 questions so that they'll let me do more video promotions for them. And of course, elastic.co/APM is where you can find a lot of information regarding APM. One more link, I promise. That's it. Elastic CC. It's happening February of next year. The CFP is open, so make sure you submit your talks. I want to see some great talks. We're going to be doing office hours in a couple of weeks, but yeah. Once again, Colton, thank you so much for hanging out with me. And yeah, anything else before we wrap up?
No, it was my pleasure. Feel free to reach out on GitHub or I don't know if you reach out to me on Twitter. I'm not on there very much, but you can definitely find me. So
you're at is it
BasePi?
BasePi. Yeah, I don't think we had that in the.
It's fine. I should have put it in my name. I don't. Like I said, GitHub is the place you'll see me more because I don't do too much social media these days. But
there we go.
There it is.
Reach out real quick, but yeah, that's gonna wrap it up, everybody. I hope you have a great rest of the day.